Okay, let's say I ask you about the value of some variable. I ask you, how much do firefighters make? Or how heavy are elephants? How much do elephants weigh? Or how long do iPhones last before they need to be recharged? Or something like that. And you answer, well, it varies. Different firefighters make different amounts of money. Or different elephants have different weights. Or different phones last different amounts of time depending on what you're using them for, and this and that. And so you could give me a bunch of different numbers, like the weights of a bunch of different elephants or the salaries of a bunch of different firefighters. And you could arrange your data in a frequency distribution. You could draw me a graph. But what if I just want to know one number to give me the general idea? One number that tells me, okay, what's the average? Or what's typical? Or what's somewhere in the middle? Not the biggest or the smallest, but right in the middle somewhere. So that's what we're going to be talking about in this section, measures of central tendency. So this is about averages and things like that. So I'm going to start off here by giving you some examples of averages that I found on the internet. I can't claim to be sure that these are completely accurate. I didn't double check them, but according to what I found online, the average beaver can cut down 200 trees a year. An ear of corn averages 800 kernels in 16 rows. The average number of squirts from a cow's udder needed to yield a gallon of milk, 345. In 1900, the average age at death in the US was 47. And I'll just mention that if this is the average, that doesn't mean that's the most common. It doesn't mean that that was the most common age, or even that a lot of people did die at the age of 47. A lot of people lived a lot longer than that. And a lot of people sadly died in childhood of childhood diseases, things like that. So if that were the most common, that's what we call the mode. We'll talk about that in a little while. But usually when we say the average, we mean the mean. We'll also talk about that. But if you know the average or the mean, some of the values could be a lot bigger than that. Some could be a lot smaller than that. How long is a normal car loan? Well, this, if you look at it, talks about averages and what's most typical. It says in 2019, the average term length was 69 months for new cars and 65 months for used vehicles. But they also say that the most typical length for a car loan is in 12-month increments, like a whole number of years, from 2 years up to 8 years. So the most common loan terms are either 24 months, 36, 48, 60, 72, or 84 months. So another example of the difference between what's the average and what's the most common or most normal or most typical. The average American shower uses 17.2 gallons and lasts for 8.2 minutes. The average wedding party in America has 4.39 bridesmaids. The average American spends 120 hours a month watching television, the equivalent of 5 complete days in front of the TV. And this was before the pandemic. We have lots of people staying at home, they're probably watching more TV. The average American will eat 35,000 cookies in a lifetime. The average elephant produces 50 pounds of dung each day. And according to the Bureau of Labor Statistics, the median wage for workers in the United States for the first quarter of 2020 was $957 per week, or $49,764 per year. Now, they didn't say that was the average, they said that was the median. So another thing we'll be talking about in this section is what the median is and the difference between an average or a mean and a median. But first we are going to talk about the mean. So usually when people say average, this is what they mean. Sometimes people say average when they mean the most common value, which is what we call the mode. But usually when people say the average, this is what they're talking about. The mean, also called the arithmetic average or the arithmetic mean, is what you get when you have a bunch of numbers and you add them all together and then divide by how many there are. Now the symbol for the mean of a variable or a bunch of numbers depends on whether it's calculated using the whole population or just a sample. For right now, that's not going to be an important distinction, but later on in the course it will, when we talk about things like estimating what's true of the whole population based on what we see in our sample. So it is going to be important to distinguish between those later on. So the symbol for the mean is different depending on whether you're talking about a population mean or a sample mean. So if you're just working with a sample that's supposed to be representative of some larger population, the symbol for the sample mean is X with a line over it, and that's pronounced X bar. If you're talking about a population mean, if you could get information from the whole population and calculate the mean from all of those numbers, the symbol for that is this Greek letter mu. It looks sort of like a cross between a letter M and a letter U, or sort of like a U with a long tail on the left, but it's actually the Greek letter that corresponds to our letter M. So that Greek letter mu that looks like this is the symbol for the population mean. But either way, it's calculated the same way, by adding together all the data values you have and then dividing by how many of them there are. So this is how you'd write that as a formula, and this symbol right here, this is another Greek letter. It's a capital sigma, which is the Greek version of our letter S. And when you see this symbol in math or statistics or science or something like that, it usually means the sum. That is what you get when you add together a bunch of numbers. So the sigma in front of an X just means the sum of all the different values of your variable. You add together all of your individual numbers, and then the N stands for how many there are. If it's a sample, we use a lowercase n to stand for the sample size, how many things you have in your sample. And if it's a population, we use a capital N to stand for the size of the whole population. But either way, it's how many numbers you added together. And let me just mention the rule for rounding. Because lots of times when you calculate this, you divide, you get a number that maybe has some digits after the decimal point. How many digits should you give? Well, the rule is, in your final answer, give one more decimal place than the original data. So that means if you were working with a bunch of whole numbers and you calculated the mean, you would give that mean rounded to the nearest tenth, to one digit after the decimal point. Okay, let's look at an example. In Class A, so this was a class that took a test, and the scores that the people in the class got on that test were listed here. Now, let me remind you that on Canvas, I have posted the notes for this section, so all of these example problems are included in the notes. If you have a printer, you might want to print those out and use them to help you follow along with the video lectures and take notes and work out some of the example problems. And if you don't have a printer, you still might want to have pencil and paper and calculator handy as you're watching these videos, so that you can work through the examples on paper as I take you through them here on screen. So in this example, we have this list of numbers, this list of test scores. And to calculate the mean or the average of all those test scores, first we add them all up together. It turns out they add up to 967. And then we divide by how many there are. There are 12 numbers here, so we take 967 divided by 12. And that comes out to 80.583333, and the threes just keep on repeating. But remember what I said about rounding. Since these are whole numbers, we want the answer with one more decimal place than just whole numbers. So we will round to the nearest tenth, to one digit after the decimal point. So there's a 80.5, and then the next digit is 8. And when the next digit is 5 or bigger, we round up. And so the rounded value is 80.6. So the average score on this test, the mean score, is 80.6. Some people got more than that. Some people got less than that. That was the mean. Let's try another example. In Class B, the test scores are 81, 83, 86, 82, 83, 85, 90, 91, 84, 35. Oh, somebody didn't do very well. Somebody didn't study. And what's the mean? Now, here's the kind of place where you could pause the video and try working it out for yourself to see if you've got the hang of it. If you think you know how to do this, pause the video, calculate it yourself, and then unpause, and I'll work it out, and we'll see if we get the same answer. And if you got a different answer than me and you can't figure out why, ask me about it. So, pause now if you want to try to do that. Got it? Okay, now we're unpaused, and I'm going to work out what the mean of these scores is. So I've got my calculator, and I'm typing in 81 plus 83 plus 86 plus 82 plus 83 plus 85 plus 90 plus 91 plus 84 plus 35, and that adds up to 800. And then I'm going to divide that by how many numbers there are, which is 10. And it's nice that it came out even, so we don't have to worry about rounding for this. So the mean turns out to be 80. Notice that most of the scores are a little bit, at least, above 80. So we got a lot of scores that were at least a few points above 80, and then this one score that was way below it. So that can happen sometimes with the mean. You can have a whole bunch of numbers that are just a little bit above the mean, balanced out by one or two that are way below it, or the other way around. Now, what if you're out of college, you're looking for your first job after graduation, and one of the companies you interview with is the American Twiddle Company. And you learn that the average salary for people who work there is $316,000. Would you want to work there? I mean, that sounds pretty good. That's a pretty good salary. Well, you dig a little deeper and you find out that there's a president who makes $2 million. There's a vice president who makes $1 million. And then there are 8 other workers who just make $20,000 each. So if you calculate the mean, you're adding together the salaries of all of those workers. They add up to $3,160,000. And you divide by how many there are, which is 10. That does come out to a mean of $316,000. But that's probably not what you're going to be making. You're probably going to be making $20,000 if you go to work there. So you got to be careful about the mean. It doesn't necessarily tell you about what the individual numbers are, just that some are higher than the mean, some are lower than the mean, and they might be a lot higher or a lot lower. Okay, I'm going to stop this video here and then come back in the next one and talk about some other measures of central tendency.